Hey, welcome to WASD's, the finals overlay and the math behind it. So we're going to go over how we derive the formulas to calculate everything and then applying it to an actual example so you can see how it works, and then you can apply it on your own. And you are more than welcome to create a spin-off of this application if you want to using this logic. So feel free to do that if you like. But basically our idea is that, starting with the hypothesis, we believe that if you have just a single flash, like it doesn't even need to be several scoreboards gathered together and then like making inferences based off of that. Oh, like this guy got a kill at this point in time, this guy got a kill later, so then in sum this guy got this many kills and whatnot. We don't need to do any of that. Our idea is just that you press tab once at the beginning of the round so we know how many coins everyone started with, and then you press tab at the time you want to calculate everything. So here where it says 404 left, that means tab was pressed once to figure out what were the initial coins, and then at 4 minutes and 4 seconds remaining, now we're calculating who is alive on which team, on like every single team, and how many people are alive on each team. So let's start with how many people are alive on each team because that's easier to calculate. So this is a variable introduction. So we have the sum of deaths on a team, we have the sum of revives on a team, we have the change in coins from the start at the very beginning of the round to the time you're taking the picture. So that'd be like 404 here. We have the change in player I's coins is delta CI, and then DI is the death count. W number of times the team wiped. P is the number of players live on a team, and then these are all revive factors. So I just want to say something really quick. When we talk about revive factors here, we don't just mean revives. We mean revives, wipes, and coins, because those are three distinct ways in which people can come back, and those are the only three ways people can come back. So foregoing the possibility of a DC and reseed, then we're going to consider a player comes back to life after they die, either through being revived by a teammate, through coining, or if everyone gets wiped, then everyone spawns together. So there's certain like mathematical properties behind that. And using this below formula, we can basically calculate the number of players alive on a team. And in reality, the formula looks like this. So the number of players alive must balance with the number of times they died less all the revive factors, and you could express that as a ratio between W and the other variables by recognizing that every time you wipe, that counts as 3 revives technically, because 3 people come back to life on every wipe. And then that's how you can calculate the number of times someone wiped. But basically you can take this one system, two unknown equation and reduce it to this formula right here by recognizing that the number of wipes doesn't really matter to calculate the number of players alive, because the relationship is that it's always a multiple of 3. So you can use the modulo function to reduce that. And once you calculate the number of people alive by this, and let's just test it really quick. So let's sum the revives on a team. We're going to sum pink first. So we're going to look at the revive column. We're going to look at 3, 1, and 7. So that's 11 total revives. Change in coins. This is a round 1 picture, so everyone starts with 2 coins. So 1 change in coins, right? So that's going to be the initial coin minus the current coin. That's how you calculate delta C, and then you sum that for each of them. So like 2 minus 2, 2 minus 1, 2 minus 2. So we have 11 plus 1, which is 12, and then minus the deaths. So the deaths is 12 plus 3, 15. So 12 minus 15 is minus 3. Minus 3 modulo 3 is 0. So if it returns 0, then either everyone is alive or no one is alive. If it returns 1 or 2, then it means either one person's alive or 2 people are alive. And then we'll specifically clear up, for example, like if you would get a 0 as a result of your modulo operation, then clearly you just look at the top left and see if they're wiped or not, right? For whether everyone's alive or no one's alive. But that actually is fully indeterminable because of the way the scoreboard reflects that. So you have to consult the top left for that. And the program automatically does that, so don't worry about that. But that's how you'd calculate the number of people alive. So pink has either everyone alive or no one alive. And let's look at orange really quick too. So they have no change in coins. So this one's a little easier. So we'll sum the revives. So it's 1, 1, 3 is 5. And then change in coins we said was 0. And the death count was 15. So it's going to be 5 minus 15 modulo 3. 5 minus 15 is negative 10. And negative 10 modulo 3. So the way to do modulo, in case you're not familiar, And let me just go ahead and delete that so I have space to write in. If you have, what was it, -10 modulo 3? If you have a negative number modulo 3, you just keep summing 3 until you get a positive number between 0 and 2, inclusive. So we're going to sum 3 once, we get -7. We're going to sum it again, we get -4, we get -1, and then we get 2. So now 2 is between 0 and 2 inclusive, right? So we're going to, it's an integer in between that. So our answer is just 2. There's 2 people alive on orange. And you can feel free to calculate it yourself. That has to hold true. And then we can also calculate like who on orange is going to be alive. But like in this case, it doesn't really matter because everyone's a medium anyways. So we just know there's 2 mediums alive. But you can calculate like which person specifically to an extent. Okay. And let's quickly check purple too, just in case. So purple has 4 revives. It has 1 change in coin, so it's 5 total revive factors. And how many times did they die? They died 14 times. So 5 minus 14 is -9. -9 modulo 3 is going to be 0. So either they're all up or they're all dead. Okay. And now using the number of players alive, you can actually figure out how many times they wiped, which will help in a later calculation, but it might not be super relevant if you're not automating the process. So those are like the 2 main equations to actually come up with the total number of people alive on each team. And then from there, you can further break it down into who is alive on the team using systems of equations. So we want to depict someone being alive on player X, Y, and Z. By the way, this will be X, this will be Y, and this will be Z. We're going to depict each of them with a binary representation. So if it's a 0, they're dead. If it's a 1, they're alive. And we know the sum of those contestant values has to be equal to P, the number of people alive, right? So if 2 people are alive, then 2 of them have a 1, and they'll sum to 2, and so on. If 0 people are alive, they're all 0, right? So this is one equation or systems of equation we need to have true. Also, how it works is for player X, so let's look at this person here, Kaiserman. This person's only comes back to life through either a revive by player Y onto player X, or a revive by player Z onto player X, or a coin by player X, or a wipe. So since it's not possible to tell exactly who this person, who Y revives, you can set up a variable relationship where the total number of times Y revives and total number of times Z revives less the times they revived each other is going to be the number of times both of them revived Kaiserman, right? This is basically coming from the math formula probability of A or B, where you sum P of A and P of B and you subtract the common intersection, right? So that's basically the idea here as well. You want to remove the times they revived each other because that's not going to be helpful to calculating whether Kaiserman's alive or not. So besides that, we just check the change in coins for themselves, the wipes, their death count, and then we add 1 just to standardize the representation so that it falls between 0 and 1. Others it fall between -1 and 0, and we don't want that. So this is the formula we need for each player. So we have this for player X, we have it for player Y, we have it for player Z. And then using that, we can solve the systems of equations. And there's also one more result, which is that the number of times someone gets revived, or the number of times someone revives. So like, for example, RY, the number of times that player Y revived anyone would be the number of times we revive one teammate plus the number of times we revive the other teammate, right? That's quite straightforward. So using all those, you can come up with the systems of equations. And it turns out this systems of equations has a free variable. So it's not solvable precisely, but there are some logic constraints because they have to be non-negative, for example, and you know the number of revives has to be less than the number of revives displayed on these column totals, that you can actually brute force it really quick. So that's what the program actually does. But for us, for example, how would we set this up and like use our own logic to calculate this? So for example, we have on orange team the number of revives by, or let's say orange team, because pink's fully up, right? So on orange team, this is going to be X, this is going to be Y, and this is going to be Z. So the number of times that Y revived is right here. That's 1. So you have 1 plus the number of times Z revived, which is 3, minus the number of times they revived each other. So we don't know that yet. So we're just going to leave them in variable form. ryz plus rzy, plus the change in coins of x. So x did not coin at all, so it's going to be 0. The number of times they wiped. We did not actually calculate that yet, so that's also something important. So we know there's 2 people alive on this team, right? So we're going to do in the formula 2 plus the sum of deaths, which is 15, so that's 17 now, minus the change in coins, 0, minus the revives. So the revives is 5, so 17 minus 5 is 12. 12 divided by 3 is 4, minus 1 is 3, so they wiped 3 times. So I'm just going to write here W is 3 for later reference. So we're going to add 3, we're going to subtract the number of times x died, which is 5 times, so we're going to add 1, and then we're going to get px from that. So we have 1 plus 3, 4, 7, 7 plus 1, 8, so 3, so then we have r yz plus rzy equals 3. That's our first equation, and we're going to do the rest for the other ones as well. I'm not going to skip ahead mostly because I don't know video editing, but you can feel free to skip ahead if you'd like. But to calculate this for y, we have the number of times x revived, which is 1 time, plus the number of times z revived, which we said was 3, minus the number of times that x revived z, and the number of times that z revived x. And then we're going to add the change in coins, so this is also 0, plus the wipes is 3, minus the number of times that person died, so it's 5 across the board, plus 1. So it's actually the exact same result, which is cool. So I'm just going to do that. And then for this last person, we have the number of times that x revived, which is 1 time, plus the number of times of the y revived, which is 1 time, not 3 this time, minus rxy plus ryx, plus number of changing coins is 0, plus wipes is 3, minus deaths is 5, plus 1, leaves us with, well, this is 2 less than the other one. I'm just going to do the math again just in case. So 2, 2, 3, 6, 1, so this is this is equal to px, right? So I think I actually made a mistake on something because I'm supposed to put in the px as well, which I did not do in the first equation. So let me do that really quick. It's not really a mistake. It's just like I need to fill it in later for assumptions. So this whole first equation is equal to px, right? So then if we simplify this, we get, was it 4, 7, 7 plus 1, 8, 3. So we have px minus 3 equals that. So px minus 3 is equal to this negative expression right here. And the same way, this would be py minus 3, because it's the exact same equation. And I'm going to get rid of all of that. And this last one, this is equal to pz, I drew an r right there. Is equal to pz, and we're going to sum the rest of the terms, so that's 2, 5, 1, so pz minus 1. So now the idea of solving this is to use logic to figure out whether this could be true or not. So we know pz is maximum 1, and what else do we know? So x has revived only 1 time, right? So we know that xy plus xz has to be equal to 1. So rxy plus rxz equals 1. And it's basically like a puzzle from there. And then similarly, we have ryz plus ryx equals 1, right? ryx plus ryz equals 1. And then we have rzx plus rzy equals 3. Okay, and I'm going to try to clear some more space for us. So let's get rid of that. Okay, and now what else can we do? So now we want to assume who was alive and not, right? So we know 2 people are alive. So let's see if x is alive. or if x is the one that's not alive. Let's say px equals 0. This is going to be our guess. So px equals 0, py equals 1, and pz equals 1. So if we do that, we get 0 minus 3, or we get, let's just simplify the negatives. We get 3 equals ryz plus rzy. And we get 3 equals, sorry, not 3, because now we have to plug in 1 for py, so that's going to be minus 2. So 2 equals rxz plus rzx. And we have 1, so 0 equals rxy plus ryx. So that means rxy equals negative ryx, so both have to be equal to 0 if they both have to be positive. So then we instantly know that solution, right? Rxy equals 0, we have ryx equals 0, and we have, from plugging this into the other equation, so rxy plus rx equals 1, so then rxz must be equal to 1. And then this should be equal to 1 as well. And rzx is right here, so rzx plus rzy equals 3, so then rzy should be 2. And ryz has to be 1 then. And ryz being 1 makes sense because ryx plus ryz equals ry, which is 1. So we have a consistent system of equations, which means this is a possibility. So basically what the algorithm will do now is it says that, okay, it's possible that Fanko Panko is dead, Sterling Archer is alive, and Rensler is alive. So it's going to return that as a possibility. And it'll be something like that. That's one possible permutation. And then it's going to do this for all the possibilities, and whatever the common denominator is, that's what's going to be returned. So in an ideal case where it's not just a triple medium, because it's pretty obvious to determine how many mediums are alive from that, where it's something like LHM, if you can figure out who cannot be alive, then you can immediately eliminate that as a possibility, and then you can only show the ones where they are alive. And we look at the common denominator of all the possible combinations, and we return that as a definite result in the algorithm, and then we put a question mark for any other contestants that where it symbolizes that another person's alive, but we don't know exactly what contestant type it is. So that's essentially how the math works. And if you look back at this Google Doc, the system of equations you can represent looks like this, and if you reduce it, this is what it looks like. This is not actually as daunting as it looks. Like, a lot of these equations are simplified to very, very simple numbers because this identity is already equivalent to something else once you expand it out. So it's very fast, very cheap computation, so it doesn't take any load on your system at all. But that's essentially the math behind calculating all this. And if for whatever reason this overlay gets banned, you can always reprogram this if you like. You have full permission to, and you can calculate the math yourself. Realistically, the system of equations is not happening, right? You're not going to be calculating that during a game, but how hard is it to do what is this, 5 plus 0 plus or minus 15, so negative 10 modulo 3. I'm going to sum 12, so now I have 2 modulo 3, which is 2, and there you go. I already know 2 people are alive on this team. It was less than 3 seconds. It's very, very simple to do this. It's very practical as well. I was doing it before we programmed this to test that it actually made sense, and this wasn't too much of an advantage. So feel free to start using this if you don't want to use the overlay. At the very least, you'll still have an information edge, or making a level information playing field. But I'm pretty surprised no one's picked up on this yet. Maybe someone did and they're gatekeeping it, but we are not gatekeeping it. It's open source. You're free to do whatever you want. Look into the program, dig into whatever. You can do whatever you want, and go crazy with it. Good luck.